everyone to Think Global Education Services SAT Math class. Guys, today the topic is progressions. So here we will be dealing with arithmetic progression and geometric progression. So guys, we'll start with AP first. So let's talk about what is arithmetic progression. We'll see the formulas that are involved in arithmetic progressions and a couple of questions to understand what really AP is and how it is actually tested in your SAT exam. So let's talk about arithmetic progression. Now, guys, in arithmetic progression, the definition is when I say that there is a constant difference between two successive terms, then the terms are said to be in AP. Or I can say to figure out the next term, if I add a constant to the previous term, then the terms are said to be in AP. So for example, if I say, let's say the first term is A, to figure out the next term, if I add a constant to the previous term, so let's say that constant is D. So the next term will be A plus D. If I keep on going forward to figure out the next term, if I add a constant to the previous term, the next term will become A plus 2D. Similarly, the next term will become A plus 3D, so on and so forth. And the last term of the sequence will become A plus n minus 1 times D. Now, sometimes students have a confusion that, sir, it should be A plus ND. Why n minus 1 times D? As we are going A plus 3D, A plus 4D. So in the end, it should be ND when I say the number of terms are n. But not really. It's actually A plus n minus 1 times D. Now, why it is so? If you look carefully, this is the first term of the sequence. Now, if we see that how many constant are there in the first term, I realized I cannot see any constant. The number of constant is 0. But if I look at the second term, how many constant I can see? There's only one constant, that is D. So there is one constant. If I look at the third term, I realize that there are two constants. So if you notice, with every term, I have one fewer constant. So with the nth term, the number of constant in the series will be n minus 1. So guys, it will not be nd, it will be a plus n minus 1 times d. Now, there are a couple of formulas that you should be aware of in your SAT. The first formula is the sum of arithmetic progression. The sum of the arithmetic progression is given to me by n by 2 first term plus the last term. Now here, guys, n represents the number of terms in an arithmetic progression. N represents number of terms in arithmetic progression. First term and last term are pretty obvious. Here A actually represents the first term and D represents the common difference. Common difference between two successive terms. These are the variables that should be aware of, and the sum of an arithmetic progression, as I told you, is given to me by n by 2 first term plus the last term. Now guys, the more important formula that we need to work here is a plus n minus 1 times d. Now this is another formula which is very important. So guys, if we talk about the significance of this formula is actually used for a couple of things. So I'm writing this formula here. The formula is a plus n minus 1 times d. Now this formula is used for two things. First, it is used to figure out any particular term in the sequence. Suppose I need to figure out the sixth term or seventh term, or in that case, if I want to figure out any particular term in the sequence, I'll use this formula. Replace the value of a as first term replace the value of n. Suppose I need to figure out the sixth term, so I'll replace the value of n as 6, and d I will replace as common difference, and I'll get that particular term. But more importantly, this expression is actually used to figure out the value of n. As we know, the series is a plus d, a plus 2d, so on and so forth, and the last term is a plus n minus 1 times d. So I can say this expression is nothing but equal to the last term. So if I know the last term, and if I equate the last term with a plus n minus 1 times d, replace the value of a as first term, replace the value of d, I can calculate the value of n. So this expression a plus n minus 1 times d is very important. As I told you, it's used for two things. It is used to figure out any particular term in the sequence, or more importantly, it is actually used to figure out the value of n. If I equate this expression with the last term, I will get the value of n, which represents the number of terms in an arithmetic progression. So guys, let's take a couple of formulas and let's try to understand a couple of questions, and let's try to understand the significance of these formulas. So let's say this is the question. Now here it says how many multiples of 3 are there? How many multiples of 3, that's important, are there between 18 and 93? And after the commas, they have mentioned inclusive. Now this is a very, very important word. When I say between 18 and 93, that means I will not consider 18 and 93. But if I say inclusive, that means both 18 and 93 will be included. So let me first write down the series the question is talking about. The question says how many multiples of 3. So I'm only concerned with the multiples of 3. So rather than saying between 18 and 93 inclusive, in simpler words, I can actually say from 18 to 93. Now, since the question says only multiples of 3, so I'll talk about only multiples of 3. The first multiple of 3 from 18 is 18. The next multiple of 3 is 21. The next multiple of 3 is 24. So I'll keep on going like this, and the last multiple of 3 till 93 is 93. So here, as I can clearly see that this series is an arithmetic progression because the common difference between every term is 3. So we are keep on adding a constant. Now they're simply asking me how many. That means they want me to count the number of terms. And I already told you how do we count. We equate the last term, that is 93, with the formula a plus n minus 1 times d. 93 is equal to a, which is the first term of arithmetic progression, that's 18. N represent the number of terms which I need to calculate. And the common difference is d, which is in this case is actually 3. Now when I solve it further, it will be 18 plus 3n minus 3 is equal to 93. Now I will isolate 3n and shift all the other numbers on this side. So 93 minus 18 plus 3 is equal to 3 times n. So from here, I will get that 3n is actually equal to 93 minus 18 plus 3 will give me 78. N will be 78 by 3, which actually goes 26 times. So here n, which represents the number of terms in the series, is 26. So guys, it's very basic. You just need to equate the last term with a plus n minus 1 times d, and you'll get the number of terms in an arithmetic progression, as I already told you. So guys, let's take one more question and try to use another formula. Now in this particular question, the question says if x is equal to the sum of even integers from 30 to 50 inclusive, and y is the number of even integers from 30 to 40 inclusive, what is the value of x plus y. So here they are actually talking about the sum of even integers from 30 to 40. So inclusive is of course the same thing because I'm already using from, so that's the same thing. Now let me create the series first. So I'm only concerned with even integers from 30 to 40. So if I say the first even integer will be 30, the next even integer will be 32, the next will be 34, so on and so forth. And the last even integer till 50 is 50. So I can clearly see the common difference is same here. So this series is nothing but an arithmetic progression. And they are saying that x is equal to the sum of this series. So x actually represents the sum, and I already told you the formula for the sum of arithmetic progression, which is actually n by 2 first term plus the last term. That's the sum of an arithmetic progression. If I try to replace here n by 2, I can clearly see the first term is 30 and the last term is 50. Now from this formula, I can see that n is still missing. Now how do we figure out n? We will just equate the last term 50 is equal to a plus n minus 1 times d, like the previous question we just did. So here 50, the value of a is the first term, that's 30, n I need to figure out, and the common difference as I can clearly see is 2 here. Common difference is 2, so I'll solve this. 20 is equal to 2n minus 2, 22 is equal to 2n, and n will come out to be 11. Now here I got the value of n. Now I can easily replace the value of n in this expression. So n being 11 by 2, first term is 30, last term is 50, so I'll add them up. 80, 2 goes 40 times, so that's 11 into 40, that's actually 440. So I got the value of x. But if you notice the question carefully, they're not asking the value of x, they are asking you the value of x plus y. Now what does y represents? Y is the number of even integers from 30 to 40. So y is actually the number of even integers which I already calculated. The number of even integers in this series is 11. So the question says that this is y. Now I have the value of x, I have the value of y, and the question simply asks me what's the value of x plus y. So x being 440, y being 11, so the answer is actually 451. That's the value of x plus y. That is option number B. So do you realize I have not used any other formula apart from these two which I just discussed. One formula is the sum of arithmetic progression. The other formula is a plus n minus 1 times t. Now, if you just know these two formulas in your AP, every question for your arithmetic progression is sorted in your SAT exam. So guys, I hope these two formulas are clear. But sometimes rather than using the formula or using the calculation, you have to be smart enough and understand the pattern of a series. So let's try one question on that also and try to understand how sometimes the question comes for a arithmetic progression. Now here I have to be smart enough and figure out the pattern of the series. Now they say in an increasing sequence of 6 consecutive integers. So we have 6 consecutive integers. I believe you understand the meaning of consecutive integer. Consecutive integer means the very next. Like if I say 2, so the consecutive integer is 3, the very next. So there are 6 consecutive integers. So if I say the first integer is a, the second integer will be a plus 1, a plus 2, a plus 3, a plus 4, and a plus 5. So do you realize I have written all the 6 consecutive integers a plus 1, a plus 2, a plus 3, a plus 4, a plus 5. This is how the series will progress. Now they are saying the sum of first 3 integers is 321. So they are already giving me the sum of first 3 integers, which is actually 321. Now they are asking me what is the sum of last 3 integers. So they're simply asking me a plus 3 plus a plus 4 plus a plus 5. Now, though guys, students sometimes feel that it's a pretty easy question. It's a very basic addition and subtraction problem. I can very well figure out the value of a from equation number 1 and replace that value of a in equation number 2, and I'll get my answer. It's very straightforward question. But is SAT testing you on addition and subtraction skills? No. The calculator in a calculator section is already allowed. So they are actually not testing you on your calculation skills. So it's not a basic addition and subtraction problem. If you look at the series carefully, the first term of the first equation is a and the first term of the second equation is a plus 3. So I can clearly see that this is actually 3 more. Similarly, when I look at the second term of the first equation and if I look at the second term of the third equation, I realize that it's also 3 more, a plus 1, and this is a plus 4. So it's actually 3 more. Similarly, the third term of the first equation and the third term of the second equation, I can clearly see is 3 more. Now guys, the common sense says that every term, so there are only 3 terms and every term is actually 3 more. So the sum of the series will definitely be 9 more, plus 3 plus 3 plus 3. So eventually the sum of the last 3 terms in the sequence will directly be 9 more and will straight be 330. So sometimes students try to figure out the value of a, replace that value of a in the second equation, try to get the answer. I'm not saying that's a wrong method. That's also correct. You can always do that. But SAT is actually testing you to think for a logic rather than going for those basic addition and subtraction. So just look at the equations carefully and you realize that every term is 3 more. There are only 3 terms. So the sum will eventually become 9 more and it will straight be 330 without calculating the value of a. So sometimes they try to play with the question like this. So you have to just understand the pattern. So guys, this is all with arithmetic progression. Very basic couple of formulas. If you know those formulas, you're good to go. Now, guys, let's move on to the next part of this session, that is geometric progression, GP. Now, what do we understand by geometric progression? If you remember in arithmetic progression, I said that if you really want to figure out the next term, you have to add a constant to the previous term. In this case, I'll say if I want to figure out the next term, let's say the first term is a. If I really want to figure out the next term, I will multiply the previous term with a constant. Let's say that constant is r. Similarly, if I want to figure out the next term, I'll multiply the previous term again with the same constant. So it will be ar square, ar cube, so on and so forth. So you see, either I can say to figure out the next term, I will multiply the previous term with a constant, or I can say to figure out, or I can say that there is always a constant ratio between two successive terms. So you can put it in whichever way you want, but the series will be like this. Now, what will be the last term? AR to the power n minus 1. Again, guys, it will not be AR to the power n. It will be AR to the power n minus 1 using the same logic by which we understood this for arithmetic progression. With the first term, how many constant? 0. With the second term, how many constant? 1. With the third term, how many constant? 2. So do you realize with every term there is one fewer constant. So with the nth term, I'll say there will be one fewer constant and it will be AR to the power n minus 1. Now guys, that's all that you need to know for your geometric progression. That is AR to the power n minus 1. That means you just need to know how will you create your general term. That's your geometric progression. Now there is the formula for sum of GP, which is actually A 1 minus R to the power N over 1 minus R, where A represents the first term, as you can see in the series. R represents the common ratio, and N of course represents the number of terms in the series. So in AR to the power N, AR to the power N minus 1, I know A is the first term, R is the common ratio, and N is the number of terms in the series. I have given you the formula for the sum. However, this formula is not tested in your SAT. So you should really not worry about how will I figure out the sum of geometric progression. It's actually a calculation intensive formula, and SAT does not like anything which is calculation intensive. So I can just ignore this formula. If you read this formula anywhere, I have not seen this formula being tested in SAT. So when you look at geometric progression, you should only focus on one aspect, that is AR to the power N minus 1. That's it. One formula, GP sorted. So guys, let's take one example and try to understand how they will put a word problem in geometric progression. So moving forward, guys, this is the question. This is a word problem. It says a ball is dropped from 248 feet above the ground level, and after the second bounce, it rises to a height of 62 feet. Now guys, since we are understanding GP, so we know this question is on GP, but in your real test, you have to identify whether the question is on AP or whether the question is in GP. Now when I keep reading forward, now this line tells me that the question is on GP. If the height to which the ball rises after each bounce is always in the same fraction of height reached on its previous bounce. So this information tells me that the next bounce will always be in the constant ratio of the previous bounce. So the bounces are actually in the constant ratio. That's why I know it's in GP. They are simply asking me what is that fraction. So basically, what is that ratio they're asking. Okay, so let's try to decode this word problem. There is a ball, and let me draw a line. So there's a ball and there's a ground. Okay. Now they are saying a ball is dropped from 248 feet above the ground level. So if I drop the ball from here, let's say it's 248 feet. Now when I drop the ball, it will take the bounce. Now when it takes the bounce, it reaches here, suppose. Now the question tells me that the next bounce will always be the constant ratio with the previous bounce. So let's say that ratio is R. So the next bounce will definitely be 248R. Now be careful guys, this is actually the first bounce. First bounce. Now if you read the question carefully, they are saying after the second bounce, it rises to a height of 62 feet. So this is very important. After the second bounce, if you do not read this word carefully, you'll make a mistake. Now after the second bounce, okay, so a ball dropped. First bounce, it reaches 248R. Now after the second bounce, do you realize it will reach somewhere here, let's say. Now this is the second bounce. Now after the second bounce, again this next bounce will always be the constant ratio with the previous bounce. So this will become 248R square. So do you realize this is actually GP, 248, 248R, 248R square. So every next bounce is actually the constant ratio with the previous bounce. Now after the second bounce, it reaches to a height of 62 feet. So I know this value is already known, which is 62 feet. Now I got an equation, so I realized that 248R square is actually equal to 62. So R square will come out to be 62 over 248. That's actually goes 4 times, so 1 by 4. So R square is 1 by 4. R will come out to be under root of 1 by 4, which is nothing but 1 by 2. So the value of that constant ratio is 1 by 2. That's option number A. So guys, that's how you have to decode a word problem and make an equation out of it. And you have to just focus on creating the GP, which is AR square. And the third term in the series is actually given to me 62. So I'll just equate it and figure out the value of R. So guys, that's it from geometric progression, and that's it from my side in this video. I hope you enjoyed it. So guys, thank you all for watching the video.